your source for JVM knowledge.
So, thanks for coming. My name is Felipe, and today I have two objectives with this talk. So, the first one is explaining you how you can accelerate continuous integration, CI, from different perspectives. And the other one, for Spanish developers in the room, is convincing you that this gets pronounced Gradle and not Gradle. Feel free to correct me if I say Maven along the talk, but I will try to say Maven also. So I'm a Spanish developer, as you can infer from my accent. I'm based on Las Palmas de Gran Canaria, and I've been working for Gradle for 2.5 years on the Gradle Enterprise team. And what we're going to see today is based on our experience building Gradle Enterprise. So I think that it makes sense starting explaining you the domain and our stack, development processes, and so on. So what is Gradle Enterprise? So basically, it's a platform that helps you with the build speed, reliability, and debuggability of your builds. From the last release, also for your Maven builds. So it's comprised of Gradle plugin or a Maven extension that instruments your builds in a form of events, send it over to the build scan server that is going to give you insights on what your build actually did. Apart from that, we have a remote build cache that is going to help you avoiding doing work that is not needed. So for building this, we have a team of around 15 people, mostly cross-functional, so we take care of everything, operations, database, everything. Our stack is, production code is Java, Groovy for testing, and Kotlin for the build scripts. We have a mono repo, around 100 submodules, Gradle submodules, and we mainly push to master. So that means that the integration is pretty continuous. We use TeamCity as the continuous integration server, so that means that we'll see some patterns around that particular server. So I want to explain why it was so pressing for us accelerating our CI experience. So the last time that we took a measurement on this, we have like 20,000 tests on our platform, and they weren't unit tests. Most of them were heavy tests that integrated with the operating system, with the whole platform. So that means that they took quite a lot to execute, and they use a lot of resources. So that means that we needed really to optimize our setup. To explain you why that test matrix is so massive. So this plugin and this extension needs to work with older versions of Gradle and Maven. That's quite a lot of possible matrix. And then also it needs to work with Linux, OS X, and Windows. These components, these, let's say, backend components, also need to work with different versions of the plugins and extension, and we support different deployment procedures. We have something called like a appliance model where we zip all together the Docker containers and a scheduler for orchestration of the containers, and you just simply provide beefy enough hardware on your premises, and we deploy it there. The other option is using Kubernetes. You can deploy our platform in your Kubernetes setup cluster. I'm saying that because that's increasing even more the compatibility and the test matrix that we have to support. So, well, before getting into there, the structure of the talk, I'm going to start explaining some horror stories. So hopefully I can catch your attention with that, because even if you don't have the scale that we have or the complexity, probably you have these problems. And then once we see the horror stories, we see the recipes and our advice is based on real experience on how to solve them. And the pictures are just for fun. It's like a sense of gloom and tragedy. Something wrong is going to happen if you go with these horror stories. And one is the slow pipelines. So for a healthy team, for a healthy culture, there are like two principles around CI. One is you don't push to CI that is broken. And the other one is before of pushing, you should run your tests and ensure that you are not going to break CI by pushing. And that's something that is not reasonable and feasible to us for teams that has CI that is always broken, that takes forever to run, or tests that locally basically makes your computer unusable because they use a lot of resources or because they take 2 hours in executing it. So that creates like a friction in the values that we say as a team that hold and the reality. So we see how we can avoid these slow pipelines with different approaches. Manual maintenance. So, of course, nothing to do with manual maintenance. We, as developers, we take pride in automation, and moreover, in a conference like this one, we really care on automation. But sometimes you can see that CI might be like a second class citizen on that respect. So what I want to show is the problems of maintaining a CI server by clicking by the configuration but with a UI instead of using code, right? We'll see exactly how we can overcome this with TeamCity, but you could use the same ideas with Jenkins or other CI providers. Wasting CI resources. So, of course, this doesn't get executed in the sky, in the heaven. It gets executed in real machines, and they cost a lot if you have a complex test suite. So you could have like a couple of horror stories. One is spending money and something that you could spend on hiring more developers, or if you have a fixed budget, you could have a CI that is under provision. So that means that your builds are always waiting for having an agent that is available. And then last, optimizing by year. So basically applying optimizations not driven by hard data, right? So just saying, well, I think that this is the bottleneck, but I don't know because we don't take any metrics on CI, so let's see. So that's obviously pretty bad. And of course, if you need to create a hard case for procurement, for purchasing new boxes, new stuff, or for spending simply development resources on that, it's going to be hard if you don't have data to back it up. So we'll see how we can measure. So let's start with the first section, that is the slow pipelines and how to solve it by using work avoidance and parallelization. So probably most of you know that Gradle is pretty good on avoiding work that is not needed. How it does it? Basically, Gradle is a form of tasks that has inputs and generate outputs. So for those tasks, developers need to define what are the inputs that affect the output in a deterministic way. So let's see a real example, a little bit simplified. If you have a compile Java task that is going to get your class path with your classes and maybe the JDK version, so stuff that is going to affect the output of the classes that is going to generate. First time that Gradle executes this, is going to generate a cache key here, hashing the inputs that you define for that task. Then, once it compiles the classes, it's going to grab the output and put it in different cache storage, let's say. And then, the next time that you execute the same task, it's going to calculate the inputs, and if it sees that the cache key is exactly the same by the hash, it's going to reuse the output. So it's not going to rerun the compilation. And the saves of that are massive, as you can imagine. There are like 3 levels that Gradle support for that. One is constrained to your branch, to your project, that is the up-to-date task. That it was like the first stuff that Gradle did around that. The other one is the local cache. So let's say that you want to swap between branches or using different projects, but the same input, the same task. That's what the local cache is helping you. Even the dynamics are the same, the location is different, right? And then the remote cache is the cool guy on the block. So it's the same, but in a remote machine. So that means that you can reuse, for instance, what CI generates, put it there, and then in your local machine you can reuse work. That's pretty cool. Maven lacks that, as we probably know, but with Gradle Enterprise, now we are improving Maven by supporting these 3 levels of caching. So let's see a pattern of this build cache on continuous integration. That's our topic. And that's what we currently use for Gradle Enterprise. So on CI, we push and pull to a remote cache that is living in a different box of the agent, the outputs of our tasks. With Gradle Enterprise also, you could have a distributed remote cache. So that means that you could have a node on Sydney, another one in California, and if your CI is in California and you are in the other side of the world, you are not going to pay the latency, right, for those downloads. And the use case is pretty typical. So I'm in Spain, I compress early in the morning, and I download a lot of code that my Australian buddies have been working in my night. So I don't want to, well, I want to build to see that everything looks good before starting. So if I don't have the remote cache, I'm going to spend 1 hour or whatever waiting for that to be built. As I have the remote cache that the CI has previously populated during the night, this is going to be almost trivial. It's going to just be downloading the results from the remote cache. Another pattern that we use and recommend to our clients is having like a seed warm the cache build at the beginning of the pipeline. So you structure the pipeline like this. As I told you before, we have like 100 some modules of Gradle, and all of them has compilation tasks. So this seed build sanity check build is going to execute the compilation for those 100 submodules, warm or populate the remote cache. Then in the next builds that are going to be executed serially, integration test, browser test, whatever, they're going to grab the compilation. So it's not going to have to execute it again. So the savings are dramatically massive. So this is a really important pattern for using effectively the build cache on CI. That's about work avoidance, but what about parallelization? This is another real example. We had a browser test for the scan servers, for the build scan server, that it was growing over time. We have a lot of tests, and it was taking quite a lot. So it was clearly the bottleneck of the pipeline. So what we decided was to split it in eight buckets, right? So this is possible because our testing infrastructure is not serving any resources. So for instance, we use Postgres, but we create an schema per test. So that means that they are isolated. So that means that it's not only your CI structure, you need to think on your tests if they are safely parallelizable. Something cool to think about this, that thanks to the build cache, you are not paying 8 times the price of compilation. If you don't have this and you don't have the build cache and you decide to parallelize the builds, you are going to have to pay 8 times that price. So a lot of redundancy. And related with the measurement topic, you should not break this too much. The scheduling on CI is not negligible, so it takes time. If you break this in 1,000 tests, 1,000 builds, the benefits are going to get negative. So you need to measure to see what is the sweet spot. And last, this is a cool feature of TeamCity. I don't know if Jenkins also provides this. It's called personal builds or remote run. So basically, it grabs your dirty state, your Git dirty state locally, create a Git patch, and send it over to the server and execute it there. So that means that if you, even ourselves, that we have a pretty efficient pipeline, is still really heavy weight on resources. So that means that it's going to block your machine, it's going to make it unusable. By doing this, you can just push it there and get the feedback that you need without blocking your machine. What is super cool is that as it's using the build cache, it's going to warm this, let's say, dry run is going to really warm the cache, and the next time that you really push the code, it's going to get almost instantaneous because it's going to grab everything from the cache. So the feedback is much, much faster. Okay, so before getting into the next section, any questions on this topic? Wait. Well, I don't know if this works. It doesn't work.
Okay. Yeah, with regards to the pre-warming of the cache, is it then like always using the local cache for those builds? Because I found out that like also uploading and downloading caches to a remote cache is pretty time consuming, like depending on the pipeline.
Okay, that's a really good question. So we disable the local cache for the seed build because the point of the local cache of the seed build is warming the remote cache. So if you have enabled the local cache, it's going to go there and not go into the remote one. So that's how it works in our setup, disabling the local cache only for that.
But so you're not losing too much time with the upload download of the remote cache.
You pay a price. You pay a price. But also as I told you, we have a distributed setup. So that means that it's going to upload it to the node that is closer to CI. So it's not massive, the penalization. But you pay a price. Any other questions? Thank you. Okay, so let's go to the next section. Then it's going, joder, sorry, electricity. Now you learn how to say joder in Spanish? Okay. So avoid maintenance waste. What is this about? Okay, this is TeamCity UI versus CI as a code. So I'm going to start with a couple of use cases, real use cases. Let's say that, well, this is for real. Our setup has principally builds that rely on Linux, but some of them on Windows. So that's the typical stuff that you want to codify just once. You don't want to repeat, okay, this build depends on Linux, this one depends on Linux, on Windows. If you use a UI, you could organize that by using templates, but it's something similar to inheritance versus composition. It's going to get really hairy, really easy if you need to inherit from different templates on the UI. By using the CI as a code approach, you are going to be able to compose those requirements easily. And of course, you are going to reuse that information. And related search, if you want to know in the future which builds of your suite are based on Windows, it's going to be as easy as doing who is calling this method of IntelliJ. So it's going to be pretty easy. The other real use case, review. So as I told you, we push to master most of the time, but we have a release branch that we use for releasing and for patch releases. So some time ago, we decided that we would like to have a development environment that automatically every single commit, a binary would get deployed to that environment from release also. So what the change how would like for that setup? You need to do some changes on your provisioning code, whatever you use, Terraform, CloudFormation. Then you need to change the Gradle, the build script to support new tasks, and then you need to change your TeamCity configuration. If you are using a UI, it's impossible to put all of that together in a code review. But if you use CI as a code, it's pretty easy. And then if in the future, as an audit, you need to understand why we did these changes, how they relate each other with Gradle or with all other code, it's impossible to do it with TeamCity or Jenkins UI. Because you have an audit mechanism, but it's not related with the rest of your code. So let's see some real code for the browser test before that I told you. So this is using the TeamCity Kotlin DSL. That is pretty cool. So let's see the code. Well, can you see it from everybody? Cool. So here we generate a subproject called Scan Server Test Browser, and we iterate over this range 8 times to create 8 Gradle builds, group 1, group 2, etc. And here we define the trigger. We say sanity check build. Remember that it was the seed build. So every time that this guy gets executed successfully, then this guy is going to get executed also after the fact. And then last we say here the Gradle task invocation. So you can imagine that if you need to scale this setup, it should be as easy, scale up or down, it should be as easy as changing this. So it's much easier if you need to go to the UI and adding a new or removing some screen. Just to see how powerful is the reuse thanks to Kotlin and the DSL that TeamCity provides. This is how we create this Gradle build type that is not built in on the DSL. So by using a Kotlin extension method, we extend this project object that is from the built-in library. And then we say a lot of stuff, but just to give you a feeling, we say we want always the stack trace to be enabled to be able to get that diagnosis easier. And also we want to use the Gradle wrapper, we want to use the daemon, and stuff like that. These get defined only once on the code. And then Gradle. So this is the guy that is creating the task. So we also iterate 8 times in this case, and we create 8 test group test tasks here. Before of creating that, we have a configuration task that basically is going to grab your source set, test source set, that in plain English means your tests living on your class path. It's going to sort them, so you have a kind of deterministic way of thinking where the tests are going, in which bucket. Then we have some assumption about our code. We only have groovy tests. We don't want to test the base classes where we store our fixtures. And then we distribute them evenly, right? So that means that in the first bucket, it's going to go always the same test and continuously like that. And then we use this cool feature of test that allows you to only execute the test that matches some pattern, right? In this case, the classes that we just extracted. So by doing this, you can see that this has 0 maintenance. So if If your code base grows, this is going to grow with it. So you are not going to have a bucket that is massive. It's going to evenly distribute those, and you don't have to annotate your test classes saying this go to test group 1, test group 2. And the same with the Kotlin DSL. If you want to scale up or down, you just need to change the spec count here. So, any questions on this? Cool. Increase CI resource efficiency. So this is the architecture of TeamCity. Probably that's well known for most of the CI providers. There is, not this button. There is centralized TeamCity server that is in charge of scheduling the agents, reporting, administrative tasks, a lot of stuff, and then the build agents. There are the actual processes that are in charge of executing your builds. Those build agents, if you have some parallelization on your pipeline, that parallelization might be because you push different branches, so you don't need to have a complex setup. That means that you are going to need to have a build farm with a lot of agents. Otherwise, you're going to have contention because they are going to be always busy. So those CI agents can be deployed into different environments. So on the left of the spectrum is bare hardware, no virtualization whatsoever. Then virtual machines, they are not super fast to recreate, but it gives you more flexibility than bare hardware. Then semi-permanent containers. You know what is a container, but the semi-permanent in this context means that we don't destroy them after every single build. So they are going to keep a state, and we'll see why. And then ephemeral containers is you just simply kill them after every single build. So which one you should select for your use case? Well, it depends at least in 2 dimensions. One is the performance. So you probably know that Gradle is pretty good about doing optimization based on a state between builds. So there is the concept of the Gradle daemon. That is a background process that is going to keep in memory some information of your configuration, and it's going to help you to avoid doing spurious configuration in the next one. And also, it's keeping a JVM warm, so that means that with time, it's going to get more and more efficient. If you have a ephemeral container setup, you are going to lose all of that. That's one of the optimization. The other one is the dependency cache. Don't get confused with the build cache. Dependency cache is for stuff like JUnit, Guava, so external dependencies that you depend on. Gradle keeps them on a local folder. And if you have ephemeral containers, at least at the moment, Gradle doesn't support like mounting host volumes into the container. So that means that you are going to lose also this optimization. There is a workaround, a mitigation that is using a mirror, like Artifactory or something like that you can collocate closer to the CI agent. So you are going to still pay the price of downloading, again, the dependency, but at least with less latency. And then operations. If your software keeps a state between builds, sometimes it's not on purpose. So you could have a browser test that should kill a Chrome driver processes after using it. Maybe you forget to do it. And then that let's say crap that gets lying around can make your machine unusable if you have too many of those. So if you have an ephemeral container set up, obviously you don't need to worry about that because you are not going to keep crap around. And if you have a bare hardware, it's going to be harder for you to recreate. So you need to have some operational expertise to understand what's going on. So what we are doing in Gradle Enterprise, we have 100, I think, build farm agents that is shared with the build tool team. And most of them are living in a cloud provider, German one, not really well known, with no virtualization. We use Salt as configuration management, so that means that we can recreate those boxes if needed. It's slow, but at least if you get into a nasty operational issue, at least you can just kill them all and start again. Apart from that, we have a small subset of that farm that is based on EC2 agents, Spot instances. And I don't know if you know how they work. Basically, you just pay for what you use with those Spot instances. You provide like a bed price. And when you request those instances, if you match the price at that very moment, you're going to get instances, otherwise not. That means that you shouldn't use that for critical workloads, but it works really well for helping you with bursts. So whenever we do a release, for instance, we need more, probably we're going to need more machines on that. So TeamCity is clever enough through a plugin to go to TeamCity, to EC2, request some of those boxes, and then start them for us. What is cool is that we use a feature called idle timeout, so we don't kill them after every single build. We keep them around for 2 hours of idle timeout. So that means that we don't lose the optimization that I told you before with the Gradle daemon and so on. So it's a mix setup. So before going to the last section, any question on this? Cool. Measure acceleration. So before getting into how you can measure stuff, you need to think what are your key metrics on your organization. There are many. I'm going to show you just 3 that are pretty important for us. Time spent in queue. So that shows you, we saw, for instance, that Windows builds were spending more time in the queue than the Linux one. So that was an indication that we should request more Windows boxes to procurement. Total time of key build, that depends on what is a key build for you. Might be deploying to development, executing a smoke test, deploying to production. That depends on you. But psychologically is what a developer thinks. Whenever this is green, I'm free to go. I'm free to go to the next task. So by seeing the total time of this, you can get a feeling if you are optimizing what is more important for your team and not the side task, let's say. Then retry ratio is how many times a build per commit needs to be run until it gets green. So with this, you get a feeling of how flaky is your setup. Bear in mind that there are different reasons for what we usually say flakiness. One is like legit issues, might be that you are pushing broken codes, testing or production code, and by seeing this retry ratio, you can have some indication that you should work on that. Might be real flakiness because your tests depend on time concurrency or whatever, so they sometimes work, sometimes not, or might be environmental issues. As I told you before, you could use a mirror, Artifactory mirror, to help you with the dependency cache, and might be not properly configured. So it's always down, and that's affecting our test, right? But to get a feeling of how much we should spend on improving that, you should have, yes, a metric like this one. TeamCity has a REST API that gives you information on that, and it's pretty cool, and I can imagine that the other CI providers provide stuff like that. We use heavily for creating dashboards like this. And then Gradle Enterprise also provides, it's not a REST API, it's a server-sent events-based API, and it basically gives you the representation of what your build is doing. So, for instance, in this case, it's giving you a build event, build requested task, and this build requested build, the task build. By grabbing this raw data, you can create your own visualization. And we have clients like Tableau that are experts on that domain, that they are creating really, really cool dashboard and machinery around that. Of course, Gradle Enterprise, we have our own opinionated view of what you could do with that data. And an example is this performance dashboard. And in here, we can see an average of the Gradle builds for this period of time. And we can see how the avoidance savings, so we are, well, it's not really clear, but we are saving like 11 minutes per build thanks to avoidance. And we can see on the 3 levels that I told you before where it's going. So in this particular build, we are getting a lot of benefits with the up-to-date, and less with the local build cache, and less with the remote build cache. But that depends on your setup. So by seeing this, you can see if you are regressing with your last changes, because this is not magic, let's say, the build cache. You need to pay attention to the new tasks that you are making cacheable, if they are working well, or if they are regressing or not. But without data, well, it's kind of hard to know what is going on. So, conclusion, so save your pipeline around the build cache and parallelization. We saw that is, in theory, really useful. I don't have data here, but I can tell you that at least for us, it's been a dramatic difference. Be aware of the trade-offs when setting up CI agents infra, so there is not a bad setup. You just need to know what kind of performance are you willing to trade off, or what kind of operational expertise do you have. Measure everything in the terms of every domain, so measure CI, measure your build. That doesn't mean that you should measure every single occurrence, because then you are going to get flooded by noise. and then CI as code. So we treat CI as the rest of your platform, as code and not as clicks on screens. So now for real, do you have any questions?
I have a dumb question.
I knew it.
Is that,
You are the question guy.
I'll go ahead and ask because maybe everyone else in the room knows, but what is Team City? I'm not familiar with it.
Do you know Jenkins?
Yeah.
It's the same, but done by JetBrains. So it's
Okay.
a continuous integration.
That was my next question. Is it part of IntelliJ or do they?
No, it's a
plugin?
different product.
Oh,
It's developed by them, but it's a different product.
right. But you showed the screenshot earlier. It looked like IntelliJ.
Yeah, because they have deep integration. As they are built for the same guy from the same guys, they have.
Okay.
I don't think that you can run that remote build, personal build stuff without IntelliJ, but I don't know.
Okay.
I don't know.
Sorry, that was just my dumb question.
No, it's a good question.
Anyone else?
Any other dumb question? No, it wasn't dumb. Okay, sorry. Can you pass the microphone?
Apart from Team City, have you experimented with other kind of CI systems that they have the same kind of features like APIs and CIS code features like the DSL?
At the moment, my team is experimenting with Jenkins, but personally, I didn't. What I know is, for instance, they use a Groovy DSL. I think that's pretty similar to that one, and I can imagine that they provide a REST API, because nowadays, a serious professional product, they provide like a automatic way of consuming the data. But I don't have a lot of experience, to be honest, to say. And I'm not like doing a support talk for Team City. So I think that Jenkins is great. I think that it's just the one that we use. Any other question? So remember, Gradle, not Gradle. We have one.
Why?
Wait. Sorry, because.
If you're doing all these builds with a Git pre-commit hook, why still go straight to master opposed to doing like a pull request model?
Well, it's because our model of reviewing works like that. We don't like having block code, let's say, on branches waiting for reviews. We heavily review the code, so it seems that it's going to get probably rewritten from the first time that we push it. So if we would go with pull request, that means that probably that code is going to wait 1 week, let's say, on the pull request branch. And then as the time goes, whenever you're going to do a merge, you're going to have probably merge conflicts because the time passed over. So we find that going directly to master goes pretty well. We use Crucible for code reviews. So that means that you just attach like a reference to the Crucible review in the commit, and then automatically it's going to get to the same space and the same Crucible review. And it works pretty well for us. I mean, you would say you are pushing bad code to master. Well, it depends on what you think of bad code. So we try not to push in code that is going to make unstable our development environment. So you shouldn't push broken code anyway. But we can push code that is going to be rewritten because it's not as polished as we want, or because we have different ideas. Anyway, we are experimenting also with pull requests. We are experimenting sometimes now I'm gonna give you a real example. We are gonna migrate from Postgres 10 to Postgres 11, and that's something that you can't really do without making unstable your dev environment. So you can really use feature toggles or stuff like that for that. You just need to work in a branch, and whenever it's ready, then you can integrate it. But for other feature, product feature, it works going to master. I don't know if I answer you. Yeah. Okay, so thank you.